Hi, I'm going to show you a demo of Archivetar. Archivetar is a tool that tries to make it easier for people with large volumes of data to take advantage of lower cost storage systems, but also have sensitivity to many small files. It's available on GitHub at Brock Palin Archivetar, and we'll give a demonstration later about using the already installed version on the Great Lakes HPC cluster. In general, data comes in kind of two different formats. We have an 80-20 and a 20-80 rule. That is, 80% of the data space is taken up by only 20% of the files. So in this diagram here shows that in files greater than 100 megabytes are the majority of the capacity used, and this measured in terabytes or petabytes actually drives the volume of the amount of data you need to store and thus the budget. But the majority of the files are held in very, very small files, which makes human performance of systems such as LTO tape, Amazon Glacier, DataDen, and others much more complicated to use and or expensive or slow. What Archivetar aims to do is to make it easier to be able to utilize these systems as well as work around certain limitations that exist in other sorts of systems. The general workflow of Archivetar is that you would sort files into large files and small files. Large files are left alone or can be optionally use Globus to automatically copy to the archive. Small files are sorted into lists. Those lists are then tarred like normal and save a index, which is just a text file with a list of the files that are in that tar. What this will allow you to do is we can exploit parallelism both by core as well as network requests to increase performance by invoking tar multiple times, but also allows us to avoid having one gigantic tar, which can create a number of issues. For example, systems like MyStorage or Turbo have a maximum file size of 4 terabytes. So if you try to create a tar that is bigger than 4 terabytes, it won't actually work on that system. In addition to that, if you want to recover that 4 terabyte tar from the archive, you need to have 4 terabytes of space and then however much space you need to be able to expand it. So if you're expanding the entire thing, assuming you didn't compress it, you would need 8 terabytes of total space, 4 for the original tar, plus 4 for the expanded version of the tar when you expand it. So by having the large files not being tarred up, it increases performance because we don't bother spending all of our time running it through tar. We don't need to spend all the time copying it. And then we only bother with the small files. By reducing the small file count by a couple of orders of magnitude, we basically end up with a directory that can be uploaded directly to DataDen. Now, a lot of these things are optional. You do not have to tell it to copy. You do not also have to specify a cutoff. If you don't specify a cutoff size, it will actually tar every single file there is in the entire system, which might be something you would want to do if you were going to archive a project and want to absolutely minimize the space by compressing everything. You would still want to possibly use the multiple tars to be able to get work around 4 terabyte file size limits, as well as being able to recover subsets of data, but it's completely up to you. So how does this actually look like in practice? I'm going to share my other screen. So in this case, I'm going to show you two different examples of using the system. In this case, I have 6,900 files. And on Great Lakes, what I would run is I would run module load Archivetar. Archivetar, you can also run module help Archivetar, which will give a number of examples, how to invoke Archivetar, as well as Archivetar has its own series of help. There's three primary commands that come with the Archivetar package. There's Archivetar, which is used to create the archives as well as initiate a transfer. There's archive purge, which takes a purge list as an optional thing that can be created by Archivetar, which is used to delete the small files that were included in the tars. So it'll delete any file that was tarred up and thus leave you only with the tars or any files that were excluded from the tars by being over the cutoff size. And then there's also unarchived tar, which is a helper command to be able to expand the tars that are created by Archivetar in parallel. One of the nice things about Archivetar is it's still creating normal tars, so you are able to expand these tars on systems where Archivetar is not installed, and thus they remain highly portable. So in this case, I'm going to be invoking Archivetar using a relatively simple setup. The very first option I'm going to do is I'm going to run Archivetar with a prefix of my archive. Prefix is required, but this is basically the name that the individual tars are going to have prefix in front of it. Normally wants to be something descriptive, so you know at the time that the snapshot was taken. By not specifying any other options, this would actually tar with no compression every single file in the directory. In this case, it's about 200 gigabytes of data. And the default setting is that each tar is 100 gigabytes in size. 100 gigabytes in size is chosen as a default because it's the size that creates the best performance on data den when requiring large volumes of data, while also not being so large that you need to have extreme volumes of storage. But this is all tunable, and we'll show you how to do that. If you use the dry run option, Archivetar will scan the file system, the directory that you're in recursively, and give you a snapshot of what's going on, but not actually do anything. So in this case, you can see we had our 6,925 items. We have 6,600 files, 276 directories, and 221 gigabytes of data. This is a histogram showing how many files kind of fall into each different order of magnitude bucket of file size. So you can see here, of our 6,600 files, almost 5,000 of them are between 1 kilobyte and 1 megabyte. So, if these were all exactly 1 megabyte, this would be only 5 gigabytes of the 200 gigabyte data, but is already well over 50% of the files. So there are 560 that are even smaller than 1 kilobyte. And then there's one file that is 10 gigabytes, and there are 43 files that are 1 gigabyte to 10 gigabytes. So that gives you an idea about what you're looking at, but it doesn't actually do anything. If I run it with two dry run options, it will go one step further. It will scan the file system, give us our summary of what it looked like, but in this case, using the default options, which because we did not specify a size cutoff, it will actually build the indexes that it would say these are the files that would show up in each tar, but doesn't actually spend the time creating the tars. So in this case, you can see that there's two different files. So you can see here in the documentation that it first tried to sort, and it didn't sort anything because we did not specify a cutoff size. So it would say that it found, it tried to sort any file that was over 1 exabyte, which we don't have any. And then you can see here, it's trying to parse, filter, listen to subsets of size 100 gigabytes, which is a default size. And you can see here that first we created my archive 1 that hit estimates will be 103 gigabytes, and then archive 2, which will be 178, and archive 3, which will be whatever is left over. You can actually see these files being created, and you can actually open these and see what files would actually show up inside each of those tars if you were to run them. But notice there are no actual tars, so this just gives you an idea about what it would do. Okay, so now if I go ahead and I'm going to remove those files because Archivetar does check for anything that starts with the same prefix, and this could cause a conflict or confusion about what files are, so you do have to delete the old ones to be able to continue. So now I'm going to go ahead and I'm going to run this without the dry run options, but I'm actually going to now specify a cutoff. So I'm going to use size, and I'm going to use a cutoff size of 10 megabytes. So this will say that any file less than 10 megabytes will be tarred, and a file larger than that will be excluded. I'm going to say I want the tar size to be 200 megabytes instead of the default 100 gig. So this is the size. So in this case, all those files that are less than 1 megabyte, they'll keep being bundled up in sort order based on directory path until we hit 200 megabytes. I'm not going to specify any compression options, and I've already specified my prefix. I am also going to save a purge list to show you the next step in the process. So if I run this, it will actually, it'll go ahead and create the sorts that we had before. But in this case, it will actually create the tars, and you can see because I'm creating only 200 megabytes each, there's quite a larger number of them, right? You can see I'm going to create 24 of them. And then as these finish, you'll actually see it come out, and it will actually tell you the final size of each one of those tars. So when this finishes, you'll be able to see absolutely everything. One nice thing about Archivetar is it does everything in parallel, and thus the performance is significantly higher than running a single tar by itself. In fact, we often see performance well over 1 gigabyte per second. So when this finishes tarring all the files, that are under that size, it won't actually delete them. So we will now have a tar of all the small files, and but all the small files will still exist as well as any empty directories. The purge list will also be saved, and we'll be able to pass purge list to archive purge, which will then go through and delete all those small files. There is an option you can give to Archivetar so that it deletes files as it goes in case you don't have enough disk space, but this is risky in the event you run into some sort of other problem in the middle of the transfer and an indeterminate state where some files are deleted, you have some tars that aren't completed, so that we recommend this as a default path if you have the space. So you can see here is now completed. I now have all the individual tars in your indexes, but the small files all still exist. So I still have my 6,000 plus files, and I have, a couple dozen more for the indexes and the tars. But now I also have this cache file. Under cache means files under the cutoff. So if I run archive purge list and I give it my archive cache, this will actually delete the files. And you can see here it is deleting files at relatively quickly. In this case, it was able to delete almost 900 files per second, and it's removed 6,400 items. So now we have 379 files, but the total amount of data is still about the 222 gigabytes, and you can see everything is here. So if I were to send this to the archive, now I've deleted all the small files, but they all still exist inside the individual tars, but these are all now ready for the archive. If I would recommend using a larger tar size and a larger file cutoff size if you were doing this, but the general idea still applies. So now I can use unarchive tar with the same prefix, which again is just from the file name, so you don't need to remember what this is. And I run this, and this will actually now expand all those tars again in parallel, and you can again control how many of these run at a time. It's automatically calculated based on the number of processor cores you have available in the system, and it's based on the number of threads. So if you have hyper-threading on your machine, you'll have twice the number. It'll be that divided by 4. The reason for that is if you do use compression options in Archivetar, you'll have cores available for the compressors because Archivetar automatically detects parallel compressors if you have those installed. So if you say gzip and you have pigs installed, which is a parallel version of gzip, it'll use the parallel version and go much faster. So in this case, the expansion is now done. So it's a very small quantity of the data, but again, it is over 80, 90% of the total files. And so I am back where I started, but I still have the original archives. So I'm just going to delete those. And I am back to my original 6,900 files. So I'm back where I started. So that's one method of doing it. The next method would actually automatically transfer it to DataDen. And so the way to do this is I'm going to change this up slightly. So here's the option I'm going to use. But let's walk, oops, sorry. Let me not actually start it. Okay, yeah. So I'm running Archivetar. I'm specifying a cutoff size this time of 100 megabytes, which reason I'm using 100 megabytes is because I want to upload this to DataDen, which only accepts files bigger than 100 megabytes. I'm actually going to increase this tar size so we don't have so many of them. I'm going to increase this to something like, 10 gigabytes or something like that. Still not as big as you probably should for optimum performance, but it will demonstrate purpose. I'm using LZ4 compression, which is not a parallel compression, but it's extremely fast. It's effectively so fast that it doesn't impact time, but it still saves some space. I have the prefix of my archive, but here's the new options. Source, this using the Great Lakes endpoint, destination, the Flux endpoint, and the destination directory. So this is the directory on DataDen archive test I'm actually going to be uploading the data to. On Great Lakes or any of the ArcTS clusters, environment variables will be set that will automatically set default settings for source and destination for the cluster you're on. So you don't need to bother with that in your case unless you need to override them, but I'm leaving them here. So when we run this, if you've never ran it before, it will prompt you for a login to Globus for a token, but once you have the tokens, it'll work automatically. Importantly here is after it created the list of files that are over 100 megabytes, it started automatically a Globus transfer. Um, Here, this is a transfer ID. And you can see here, because I specified that I wanted the tar size to be 10 gig, all the remaining files actually fit in less than 10 gig. So I'm only actually creating a single tar. But notice, because this transfer already was submitted, the large files, which are like 80% of the data, we're already transferring that data to DataDen because it's already a large enough file size. While the smaller files, we're tarring them. So we're not waiting for the tar to complete on the small files. We're already transferring the big files. And I'll show you how this looks. So if I go back over to my web browser and I look at my Globus activity, you will see here, archive tar, large file list, my archive. So it actually tells you prefix. You have multiple of these going at once. You'll be able to tell. And you can see this transfer is already running. It's not going super fast, only 600 megabytes a second. But the point is that the other tar is still completing. And basically, as the tars are completed, they will also be submitted as their own Globus transfer job. So effectively, what this means is we don't waste any time. So while I'm spending the CPU doing decompression on the small files, and I'm spending time doing and disk IO on the tar itself, I'm also spending network time and disk time transferring files. So I'm trying to never leave any resources on the floor, with the intent here being that while my tar for my small files is still not complete, I actually have already moved 45 gigabytes of data, and you could see for a really, really large project of many terabytes of data, how this would become even more beneficial, because you might have several tars, and those tars may end at different times. They will be submitted, and thus they will start transferring, as soon as their individual tar is completed, not waiting for all of them to be completed. When archive tar finishes, that just means it has finished tarring and has submitted all the transfers. It does not mean all the transfers are complete. So you need to actually come to the Globus UI and make sure they all finish before you delete any files from the original source file system. But a lot of our users are actually able to take advantage of this in a way that they're able to actually avoid having high-speed storage systems like Turbo or others. When working with large volumes of data, they effectively can get by with using Scratch on the HPC cluster, have their expanded data sets and work with it there. And then when they're not working with data, Archive tar is so efficient at compressing and bundling up large volumes of data that we can take entire folders and shove the entire folder into the archive and vice versa. So basically we can go all the way from the top tier Scratch storage all the way down to the absolute lowest cost archive storage easily, and work around the limitations of only files larger than 100 megabytes, or poor performance with small files, or just the performance related to creating one gigantic tar, or using a serial compressor or something like that. So that's it. If you have any questions, feel free to reach out to us at arcts-support@umich.edu, and thank you.